I'm gonna start here just by opening this traverse that we see here. So I'm just gonna drop right into this traverse over here. And we're also going to, I'm also going to write a legal description for this. So we can be looking at that as well as the traverse and the drawing at the same time. So let's see. There we go, legal description report. Now, I want to talk real briefly about the styles. The default .xml style is set up based on, gosh, I lost the name of it. I'm sorry, Wattles, I believe. Legal descriptions and all. So that's what we're going to be seeing. I am going to make a couple of changes in here. Courses. Let's, yeah, label the courses and stuff so that make it easy to compare what's where. So let's go ahead and generate this legal description for this traverse. Do you want to save? No, I don't want to save the changes. All right. So now I've got the legal description report for this traverse, and we'll see if we can't get all these windows arranged so that we can see everything. Okay. So here in the legal description report, we've got S1 to S2. All right, so this is our legal description. Now let's take a look at the traverse view, and then we're going to start digging in. And if you have any have questions, write them down, put them in chat, whatever. We'll try and get through all this and hopefully get to some questions as well. All right, in the traverse view, if you are not aware of this, the traverse view by default displays random inverses. All right. So what you're seeing here may or may not be the actual underlying raw data that created the coordinates. Just something to be aware of. The way Traverse PC works, as soon as we get enough information to calculate coordinates, that's what we do, and we display the inverse information between those coordinates. That's the default in the Traverse view. Now, we can always go into view and display that underlying raw data. And this is how we're going to be looking at this today. So we're just going to look at the underlying raw data. We're going to simplify this so we don't have too much in play. Let me just turn off the delta and PR to PT. Just being there's no raw data in there, that'll get those out of our way, make the view a little bit smaller. All right, so now we can see everything. And we will go ahead and delineate the points as we go along. So you can see in the drawing, let's go ahead and zoom in a bit on this. And then we'll just work our way around. So you can see that we're at this point, and I'm not sure. There we go. Just needed a regen there. So you can see we're on S1 in the traverse. We're at that point in the legal description. And as we go through this, you're going to see how this works. So initially, we've just got a couple of tangents, a couple of just bearings and distances going in. So here's our S2, S3. All right, so these are just straight lines coming in up to S4. Now S4 is where we're starting our first curve. So in our legal description coming into S4, we're stating that we're going to the beginning of a tangent curve. All right, so this is going to be a tangent PC for this upcoming curve. All right. So this then, our data on curves is always shown on the PT of a curve. So this curve is tangent to the preceding line, and this point is now going to be both the PT for the previous curve and the PC for this next tangent curve. This is a tangent PCC right here. So in our legal description report, let's see, S4 to S5, this is our curve information for this tangent curve. And as I said, the wording here is all based on the wattles. So, and then we're going to another curve that is tangent to the previous curve. All right. So that is S5 to S6, you see in the legal description, and our data is here. So this is a 5-foot radius curve to the right. All right, and you can see that in the legal description here as well. So now this is where it gets a little bit interesting. And all we've done here is we've just entered a radius and an arc length, and that has kept these tangent. Now we're going to go into a non-tangent curve, and it's going to be a reverse curve. In other words, a curve to the left. That's here from S6 to S7. So what we can see here is that we have given it a chord bearing and distance and a negative radius, so that by giving it a chord bearing and distance, it is a non-tangent curve. All right, anytime you're entering directional information, it will be a non-tangent curve, maybe close to tangent, but it won't be tangent. And curves will only be tangent if the coordinates of the PT have not been computed previously. So keep that in mind. You're not going to be able to create a PT, enter curve information on it, whether it's a radius or whatever, and have that be tangent. The only way it's going to be tangent is if we just enter the curve information and then Travers PC will calculate it as a tangent curve. So in this case, this is a non-tangent reverse curve, and what you see here in the legal description, we're going to the beginning of a curve being a non-tangent reverse curve. All right, see that here. And then we're going to go along the curve. Here's the curve itself to another curve, another non-tangent reverse curve. That is going to, so this is going to be a curve to the right, and being non-tangent, we've entered a radial bearing in this case, along with our curve information. All right, so we've given it the curve information we want, including a direction. All right. So we've entered that here. So this is a non-tangent reverse curve because we went to the right when we were going to the left. All right. So that's what's stated in our legal description report. Okay. And S7 to S8. This is our curve here. And notice that we're going to a point of cusp. All right, so because of the way we did this, entering the PC to PR of this curve, we are able to actually have a, come on, get the right spot here, get the right window active. The delta automatically then became greater than 180 because of the way we did this. Now, if you were with me in last month's curves and spirals session, I told you that you can't enter a curve with a delta greater than 180 in the traverse. Well, I've learned something since that time, and this is how it can be done. If you enter a radial bearing, you could then enter your radius and arc length and have it be greater than 180. Okay, so and that is where we're coming to S8 being a point of cusp. Okay, said point being a non-tangent PT. In other words, the tangent coming out of this it is not tangent to this curve either. Now we're going to go to a cusp PC, and once again what we're going to see here is that we've entered a radial bearing and our curve information, this allowed us to create a curve with a delta greater than 180 degrees. All right, so that's what you're seeing in the raw data here. And from here, then let's get to the right spot over here. So we're down, so here's S8 to S9, this northerly line here. Here's 9 to 10. And then this is going to take us to S10 to S11. And this is going to be a reverse point of compound curvature. Okay, so non-tangent, it's reversed, it's going to the left instead of the right. Here's the information on that curve. And once again, we're coming to, in this case, a tangent reverse point of compound curvature. Okay, so we're coming up to S11 here. And then the curve from S11 to S12 right here. So in this case, for this curve, this was a for 10 to 11, it was non-tangent because we entered chord information, and that defined the PT. Remember I said before it wouldn't be tangent unless we're just entering the curve information to create it. Then it will be tangent. Okay. Then we're coming to S12. Let's zoom out just a little bit so we can see a little more here. To S12. So this is once again a non-tangent curve to the right. All right. And that's right here in the legal description. So now we're going to go to a non-tangent PT. All right, so this is point 12. Sorry, I shouldn't have clicked there. And then we're just going non-tangent bearing and distance here in the traverse to bring us down to S13, which is going to be, once again, a tangent PC. Yeah, we just did a bearing and distance to get us to this tangent PC. Our PT, we've just entered our curve information. It's a curve to the right, so it is tangent. And then we're going to, and that is over here. Here's 13 to 14 in the legal description report. Okay. And from there, we're going tangent to that. This line is tangent. All right, right here. This is tangent to this previous curve. And if you remember, the way we can enter this is just by pressing the space bar, and it will recall that outgoing tangent. So I've just hit my space bar to recall that outgoing tangent bearing. All right. And then I can enter my distance. All right. So I've got a tangent coming out of the curve. Then we're going to come down to this is going to be our PC for a non-tangent reverse curve of there, non-tangent PC, and then 15 to 16, here is that curve in our legal. All right, so it's a non-tangent reverse curve to the left. We entered the chord. Non-tangent here. We entered the radial bearing and then the curve information. And then our final course, going back to, accidental right click, going back to our original point of beginning, this is then a non-tangent PT, it's non-tangent, it's a curve to the right and returning to our point of beginning. Okay, so that's curves. That's a detailed in looking at it. Okay, let's move on and take a look at the spirals. Going to get into them and then we'll open it up for any other questions. Let's jump over to spiral phrases. As like I say, we're comparing legal description, and this file was created for the legal descriptions, but it really lets us delve into the curves more in depth. So let's go ahead and open that traverse. And all right, once again, we'll simplify this a bit. And we'll just look at our raw data. So, there we go. Get this sized, and maybe take it off of single row, stretch it out a little bit. Okay, so once again, we're looking at raw data. In this case, we're looking at spirals. And you'll immediately notice right here, we have no raw data here. So that indicates to me that this point, and same here, these 2 points were created completely using the COGO tools. All right. And I think we'll see why as we work through this. Okay, so let's work through this. Oh, first of all, let's write a legal description. And, you know, I'm going to leave that stuff turned off. I'm just going to do it without that. It'll still have sections and we'll be able to walk through it, but maybe it'll be less confusing to us because we'll figure it out as we go. So here's our legal for this one, starting at a point of beginning. And here we've got, let's get the point displayed right here. Okay, so we're up here at point 1. All right. I'm sorry. Point 11 looks, oh, we've got background clearing is wiping out some of this stuff. Let's get well, nah, we'll leave the labels on there for now. So we're at point 11 and from 19. All right. So this is a spiral with an incoming radius, with an incoming radius of 400 and an outgoing radius of 0. All right. So this is a spiral curve along a highway spiral concave to the southwest, having a beginning radius of 400, ending radius of 0. Ending radius of 0. So that's our spiral here. And we're coming down, whoops. This is a non-tangent, just a straight course, a straight tangent down to the southwest to the beginning of a spiral. All right, so we're coming into this spiral here, southwesterly distance 300 feet, concave to the northwest, ending radius of 2,000 feet. All right, so that's this spiral here. So what we've got is tangent to spiral, and then a spiral to a central curve. Whoops. And then the central curve down to another spiral. So this was created using a PI. And if you remember, what that did is when we brought in the spiral dialog box, and we looked at this last month, so because we had a PI, we were able to enter a radius for a central curve and then just give it basically our lengths for our spirals. All right. Along the curve and then along the spiral. All right, so that brings us down to here. All right, and then we've just got, just a bearing and distance going out of that, and then we're coming to a non-tangent spiral PC. I'm sorry, tangent spiral here at 13 to the a spiral, into a spiral, and in this case, distance of 500, to the beginning of a highway spiral concave to the northeast. All right, so here is this spiral with a beginning radius of 400 and an outgoing radius of 300. And you can see that labeled here. So this is just a simple spiral that was done here when we, without using the PI, we did the spiral and just told it what radius we wanted on both ends. I think you've got the idea. These are just simple spirals where the starting radius and ending radius are different, and tangent and non-tangent to them. So that's an in-depth look at these. Here's a question. Can you talk about the difference between entering curves with COGO as opposed to in a traverse? I did this last month, and the bottom line on this is it's much easier entering them in the traverse view. And that is because, let's get back to curves. That is because just by nature, curves have so many ways to define them that you can see in this traverse the I thought I did. Let me okay, so raw data. Okay, there we go. All right, so you can see the amount of information that was entered here. All right, it's just a few little pieces, and because the traverse view was set up for the data that we wanted to enter, then that made it very easy to enter these curves. All right, whereas if I go to the horizontal curve dialog box, there are just so many options and things get locked down and you have to release this, release that, do other stuff to get what you need. It's just so much easier to just do it in the traverse view. If you're used to using the dialog box, that's fine. You know, I have nothing against it. If that's how you want to do it, that's fine. Now, you don't have to do it. Not everybody does things the same way, okay? Just for me, I just think it's simpler to do it in the traverse view, but if you like using the Kogo dialog, that's fine. Okay. Okay. Okay, so you see the difference. That's, you know, that's really the difference is not in the result. The difference is in figuring out what you got to do. So if you format your traverse view, it just seems a lot easier to me. Your cursor will track along with it if you format your traverse view properly, and you won't have to be hunting around, okay, where is the field I want? Okay, so that's it. That's the difference. All right, any other questions on the curves and spirals today? Okay, Carl.
Okay, good evening. Are you hearing me?
I hear you, Carl.
Okay, all right. Sorry about the interruption earlier on. I had a dog that was out of control.
Trust me, I understand that.
Yes. If I want to insert points on a curve, or sorry, a spiral or a tangent, I can do that within the traverse, right? For instance, I'll give you an example. Between S11 and S12, if I want to do a stakeout every 10 feet,
okay.
I can do that. I can do that within, and I want it to fall right on the tangent or the spiral or the curve. Can I do it? I can do it within the traverse.
That is where you will do it, but you will use a specific tool for that. The reason being, if I were to just start inserting points here, I would have to be entering the data for each curve, and keep in mind that the underlying data is still here for this curve. So as it recomputes, I would be extending this and it would just be swinging further around. All right,
Okay.
because of this raw data. But so we do have a tool here. Let's do S11 to S12. So the way you would do this, and this is how, if I just want to put 1 point on this curve, it doesn't matter if I want to put 1 point on this curve or all these points on this curve. I would do it the same way. So if I want to put a curve, say 15 feet along this curve, all right, just 1 point, what I would do is I would choose Kogo multiple points. All right, now I only want 1 point, but I'm going to use the multiple point tool, and I'm going to tell it that I just want a horizontal distance 15 feet, and it knows that that is along the curve, and all I want is 1 point. And I compute it, and it creates that point on the curve. Now at this point, what you have to realize is that this point was created with a Kogo tool, So there is no raw data behind it. So it is where it is. If this traverse gets recomputed at this point, see, the raw data is still here, and it would extend this then another 15 feet because I put this this point in there on the curve. Okay, so you have to be careful once you get into this. All right, you need to be careful. Now, the rest of what you were asking, if I then want, sorry, that was a accidental click once again. If I want to put points on this curve every 10 feet, yes, I would. There are a couple of ways to do this. I could either station it or I could do multiple points. So I would come in here and I would say I want one every 10 feet. And I'm going to release this, and it calculated that it'll give me 5 points. I go ahead and compute it, and now I have points on that curve all the way around. But once again, realize that if this traverse gets recomputed, this is going to be a mess. So at this point, I would probably at this point want to protect this point right here, the PT of this curve, so that it does not get recomputed unless I tell it to. So I would go ahead and protect that entire, well, actually just its position, so that I could edit other parts of it, but I would protect its position so that it won't get recomputed. Let me just talk briefly. If I wanted to station this entire traverse, I could do this. If you haven't seen this, I could go to Kogo Stations, and I could tell it that I just want points every 25 feet along the tangents, and on my curves, I want points every 10 feet. All right, now realize that this would put them on the stations then. All right, so, okay. So a couple of ways to get what you need there, Carl. All right. Thank you all for joining me, and keep staying safe, and let's hope we have a better summer than last summer was. So.